Exciting subject of web application security. This subject is kind of ostensibly titled, How to Build Zero-Day Self-Defending Web Apps. What that means is there's some key concepts. Everybody's pretty familiar with input validation and output encoding, or at least they should be. Session handling, not so much. So what happened is, it's a little too loud. What happened is I put together a presentation on some different ways to attack web applications by attacking session strength, pointed out some different platforms that kind of do things in a sort of silly fashion, like IBM's WebSphere, showed the ways people implement in the real world lead to a couple different attack vectors, and even how to attack applications from across the internet that are internal. One of my favorites are the security appliances. Many of these security appliances have web-based administrative consoles, and you can do some really fun things remotely from across the internet. And I presented this in Amsterdam at Black Hat, and the same week I presented this and was explaining what was going on, people started circulating attacks in the wild to attack eBay. And in fact, there were a couple of clients of ours that we knew were vulnerable at the same time, but it was kind of interesting timing. The exact same week, people were kind of going after this in the wild. Because of the short time frame we have, we're going to have to really condense things here. So we're going to skip over. We're not going to give much background here. I'm going to assume that most of you are pretty familiar with web application security. You probably know what the scanners are out there, have run some, hopefully get some manual testing. We're also going to introduce Project Courageous. One thing that Daniel and I have noticed over the last few years is we keep giving the same recommendations to people that never get implemented. Developers go, we don't know how to do that, it's too hard, it's et cetera ad nauseum. So we said, hey, this stuff is not hard at all. I mean, input validation, you take a .NET platform, it takes 5 minutes to write some regex validators, and most of your frameworks like Struts and Ruby on Rails, you can make global changes very quickly, but people still don't implement them. So we finally said, well, why don't we just write the code and provide it to people for free? So we're also going to introduce you what's called Project Courageous that Daniel and I are launching, and we're going to be writing components for session handling that also we discovered have some other interesting added benefits. These are going to be free, they're going to be open source, we're going to publish them and make them available. We're starting with .NET, we'll go to J2EE and Struts probably next, probably Ruby on Rails right after that, and kind of get feedback on what people want to see. So, should have pulled that slide out. Oh, nobody's seeing slides, well that's good. Sometimes my Toshiba forces me to reboot to sync. Let's try this. Okay. What's the maximum refresh rate on that projector? Do you have any idea? Yeah. I'm just going to have to bounce it. So we're going to go ahead because unfortunately I'm going to have to reboot my laptop. Sometimes my Toshiba won't sync after it sleeps. But that is okay. So, introductions. My name's Aaron Evans. I work for a little company called Fishnet Security. I work in the application security group. I kind of run a team of people who test things. Daniel works for a company called Secure Passage. They write security software. And we've known each other for a long time. And I roped him in on this project mainly so I could be lazy and force him to do some things while I could build PowerPoint slides and hide my lack of ability behind them. Project Courageous. So what we started this to say, hey, let's add some strong session handling. And I first unveiled some of the concepts of this over in London at a project, and somebody pointed out, they're like, hey, wait a minute. If you do what we look like you're doing, you're going to probably break most of the ability to do automated scanning of websites. I said, well, that's interesting, we might. So the project got the nickname, which there's certain people in the community use when we aren't a fan or endorse, but some people started calling it scan fucker, pardon my French. So But this is not the goal of it at all. So start out with session handling. One of the biggest problems in the web is it's completely stateless, which you should know. When you authenticate, right, there's no way to track a user to an actual given action. There's many problems with this. Part of the reason is the browser itself has no security model, etc. Many people have, yeah, it'll do that until it gets to the desktop, and then it'll dump. Many people's sites are vulnerable not only to things like cross-site scripting, but a term that's used out there, cross-site request forgeries. Some people call it advanced cross-site scripting. Some people call it session writing. Essentially what it means is I can embed calls, say on my website or in an HTML email, that upon viewing, I can take action on your behalf. And I may show you, if we have time here, some Nokia exploit code. We found some vulnerabilities a while back in Nokia's IPSO, which are all fixed now. We never published the actual exploit code at the time. Most of the vulnerability alerting services, I was very disappointed to see, downgraded this. They said it was a very low-grade exploit because it couldn't be performed remotely. And how wrong they were. Because what happened is when I published this advisory, guess who came to my website to read it? Thousands and thousands and thousands of people, probably quite a few of them Nokia administrators. So while their browser's happily reading my advisory, telling them what mitigating steps they can take or what code versions they can apply to the IPSO appliance, while their browser's reading my site, I can also use their browser by proxy and call, and I can look for those devices. And I'll show you how here pretty quickly, hopefully. This is not looking good. No. No, it is not. It is, let's drop this down even lower. Okay. Or you just turn the laptop around. Yeah. So evidently these projectors are a wee bit old here. I'm going to do low res, low refresh. So now I've wasted about 7 minutes of your time watching this fun stuff. Okay. All right, back on track. So, introduction slide. Arian and Danzy. What this subject is about: lack of understanding of session weaknesses, limited documentation on what's out there, limited documentation on proper use of tokens. The documentation you will find, like for example, if you dig into WebSphere, IBM has two different handling objects. They've got a default session handling object, and then they've got a little function call called like IBM.secure.session handling. I haven't found the secure in it yet, but you know, rest assured, I'm sure there's some benefit I'm missing. We're trying to condense 60 minutes of material into 15 minutes here. First of all, cross-site scripting. What is it? I don't know how many of you feel you really understand it, but people don't step back and look at the actual attack vectors for cross-site scripting. So people happily take their web app scanning widget and run it, and they find 18,000 instances of cross-site scripting. And I see very little thought put into how to prioritize and what the dangers are. I see the extreme of getting too worried and then the extreme of not getting worried enough. A common comment people will say is, hey, why do I care about cross-site scripting in a search field on my website? Or why do I care about it at all? I don't take credit cards. And then we go, now you do. So we'll show you some of that stuff as well. Cross-site scripting, request forgeries, we talked about that. And so hopefully you've got a bunch of slides in here you can read for background. One of the most important things is HTTP and session management. If you go read the RFCs, they're clearly designed by spec to be lightweight and stateless like Mike's girlfriend was. You know, there's no thought put into session handling. And the RFCs, what is it, 2109 and 2956, both say that the session security has been designed to make the least possible impact and overhead of the protocol, which obviously is not a good thing. Another problem that we have here is what I call the problem of particulars. Most of what's out there in terms of white paper, it's very hard to find a book that actually covers these subjects. What you find are white papers from vendors, and it's called the problem of particulars or bullet points. Bullet points sell. If you can find the new version of cross-site scripting or HTTP response splitting, you get a lot of notoriety, and then all the web app firewall guys can come out and it's another bullet point they can add that they protect against. Nobody puts real thought into, hey, there's some simple ways to stop entire classes of these issues. Very simply, not a lot of work, but all the focus is on finding these new little ways and hyping it up, and you know, also there's no metrics, what's really being exploited, what exploits result in real loss, very little discussion about that. So I want to give you a short, sweet categorization or taxonomy for cross-site scripting. When you look at the body of a request, when you look at an HTTP request, you've got a header field, obviously. Within that header, there's an URL. URL parameters, those nice little things you see in your browser. The only attack vector that's used in the real world, if anybody has seen another and has any evidence, please show me. I've posted this to lists saying, somebody show me differently. The only attack vector used in the real world is URL-based parameters. Because you can put those in a hyperlink. You can send an email to my gullible mother who says, first 200 users to log into our new app win $50 today. You know, she might not get it till next year, but she's still going to click it, hoping she's the lucky one. So people will embed links and forums and different things like that, but it's all about embedded hyperlinks. You can do posts and things like that, but it's URL-based parameters is what people attack with cross-site scripting. The vulnerabilities, however, can be found in header fields. They can be in body-based parameters. Now, often you inject through an URL-based parameter, and it winds up in the body and persists later. But the attack vector is through the URL. And this is important, and I'll show you why. There's other script breakdowns that we don't have time to go through. You can kind of read through these, and do we want to show? Again, another way to think of this is second to in order code injection, like the example of Nokia. So what I would do in this case is I would embed calls to an URL on my site, and I would set up a little bit of JavaScript that would look like this. So we all know what the RFC reserved IP space is, right? So while you're busy happily reading my Nokia advisory, what I do is embed calls on my website. And usually I'll pick like .1 and .254 to go to, and I'll kindly increment through like 192.168.0.1, .1.1, go through your 10 dots. And then the example here is what I would do is add this script here. Because what's going to happen is while you're reading my website, your browser is happily going to go to all these sites, right, and make this request. And what this request is, this is actually the exploit code for my Nokia. So if you're reading the advisory, it's probably because you're not patched. You want to take mitigation steps. If you're the administrator, there's probably reasonable odds your browser may have a valid session token to log into that box. You might have already logged in to look at things, look around, change configs. You're reading the document. If you happen to be on my website at the same time you've got a valid session cookie for that Nokia machine, I just created an administrative account remotely. I can down the firewall daemon or ISS is real secure, change whatever I want, all through the happy joy of you just viewing my website. I'll give you all my personal website later. Make sure you visit it from work first chance you get.
But he's got to click on that button. Is that full?
No clicking required. Because what happens in the Nokia example? No click whatsoever. What I do is I embed a call. That's not a post. This is an HTTP get. I make a get, and then I have this script in there. Because in the case of Nokia, they log all HTTP that goes to the HTTP interface. So if the administrator's browser goes to the interface, it logs it. And Nokia very wisely chose to dynamically encode and render in HTML anything that gets logged. So this script will get logged verbatim. Then while the browser is there visiting it, guess what's going to get rendered in there? That script will be rendered and execute. If you do it in, say, a pop-under window, the administrator will never notice that pop-under window is running, creates an administrator account, and okay. So we're going to jump back here so Dan can walk through some code. Limited background. If you go through, there's a lot of papers you should read to get background on this, and just because of the short time we have here, we're going to have to skip most of this. There is a neat tool that's been fairly well ignored that Anton Rager wrote called XSS Proxy I encourage you to go check out. The guys at SensePost have done some interesting work with human detection, which we'll talk about. So the issues which you hear in web application self-defense: input validation, output encoding, strong session handling. Concepts: we don't have authorization enforcement, human detection, and anti-automation. These concepts are predominantly missing, and they're easy to attack. So what do we want to do? The first thing we want to do is set strong session affinity tokens, and want to introduce a concept of dynamic authorization tokens. It's a one-time token. It's one time per request. The software we're going to provide you for free is going to generate those tokens. We're going to have two phases of the project. The first one is plug-in. You'll just drop on top of your app. You won't have any association with the user. The second phase will be extensible, and that'll mean your developers will be able to associate this code with the user. And there's some thresholding and profiling we'll show you how to do, hopefully in a later presentation with that. But initially, what we're going to do is put a one-time token. We're going to put a one-time token in the URL. Then we're going to encode the URL. This is to stop these cross-site request forgery type attacks. For example, if Nokia, in their wisdom, had decided to put some form of a token, like this example here, if they'd put a one-time token in there, I wouldn't be able to make that request on behalf of the administrator because I couldn't go to default URLs. You know, the eBay attacks that were floating around out there in the wild were based upon the idea that all you had to do was put your bid information and everything in a URL string, and it's a static resource. So anybody who'd view that link would up the bid for an eBay item. Well, it'd be pretty easy if there's a one-time token in there and that one-time token was destroyed upon use. What happens is things like cross-site scripting, cross-site request forgeries, they go from attacking all users all the time to one user one time. Very small attack surface. And we're going to make it even better. We're going to make it so you can't do it at all. So, putting authorization tokens in. We're going to just skip the slides and we'll go straight to some examples here. Are you ready to plug in too? Okay. Let me flip through this. So to give you a summary of what's here, take a given URL and you've got a given URL, like this foreign page example right here. That's viewable. So an example is you put your script in here. Here's a silly script example. Everyone knows they'll usually throw document.cookie in there. This is how people would attack, say, cross-site scripting. Well, first we're going to throw a one-time token in there. This would be the next example. This one-time token will stop that attack. You would have to go and get a one-time token. And in fact, if you don't set one-time tokens until after the user logs on, well, then it's really hard, right? Because all you can do is attack yourself. In this first phase, we're going to give you the ability to set one-time tokens in your application in the URL, but not tied to a user. So you can attack one user one time with one token. You'd have to go harvest a lot of tokens and send individual links to every person you spam. So it is possible, but it definitely raises the bar. Once we tie this to users, it goes from possible to highly unlikely. Now what we've also done then is we're obfuscating the URL. This will break the browser's back button, but in the example of if you have a client or you yourself have a site that has 18,000 instances across site scripting, you go, what do I do? You're going to drop this in front. It's going to put one-time tokens in the URL, and then it's going to obfuscate it. And this is an example of this. So what happens is URLs are going to be completely remapped, but not like the normal remapping where if you type in the native URL still gets accepted. We're going to drop all native normal URLs. So someone can't actually pass an URL with a script in it. We're only going to take obfuscated URLs. So we're going to pass the user an obfuscated URL that is the overlying surface of this one-time token. So there are no parameters exposed. So while you take your time to figure out your input validation, you got all the time in the world because none of that's going to be exposed up there. People can't do cross-site request forgeries. People can't do automated attacks. They won't be able to inject into your internal apps from the web. And another thing we found out is when you get into automation, what? When you get into automation, when you have that, automated scanners and harvesters can no longer map out a website, right? Because it never ends. So there's some human detection elements we'll talk about later. If you go visit the URL on our website, you'll be able to find more papers on this. But essentially, they'll run forever because every link is unique and it's endlessly generated. And most of your scanners, they scan and then you hit audit, when they go back to do their audit checks, guess what? They won't work because those URLs don't exist anymore and those tokens aren't there anymore. So when the bad guy's trying to scan your site and then audit it, they can't. They'd have to go through and do a check at the exact time they make every request. There's no building a map and running back and doing all this SQL injection and cross-site scripting checks. So we've been told that we're, unfortunately, out of time. Do we have 3 minutes to walk through breakpoints of code? Or can we beg and plead? Yeah. Do you care if we just do a real quick walkthrough, or? Oh, okay. Yeah. Okay, well, thanks to my... Yeah.